This video is going to demonstrate how to write programs using value returning functions. So we use functions in our programs to modularize them, to make them easier to debug, modify, to read. It's an organizational tool, but the real goal behind functions is to make tiny little programs that are reusable, that we can use in more than one place. So the goal of a function is for it to be self-contained. Everything that it needs should be part of it, the variables that it needs and the code that it needs. Data can be passed into it, and sometimes data is returned. If data is returned, only one piece of data will be returned. And that's the type of function we're going to be using in this program. So if we look at our problem specification, it says create a program that calculates and displays gross pay amounts. The user will enter the number of hours an employee worked and his or her pay rate. The program should contain 4 value returning functions: main, get hours worked, get pay rate, and calc gross. The main function should call each of the other 3 functions and then display the gross pay on the screen. Allow the user to process as many employees as they want. Use the sentinel value to end the program. So a good way to start with these is to do a hierarchy chart and to figure out how the modules relate to each other. So in this one we have our main function, which we've been writing all along. That's a value returning function. If you remember, it returns the value 0 to the operating system when the program ends. This is generally our controlling function in a program, and it calls the other functions. So main will call a function called get hours worked. We'll also call a function called get pay rate and a function called calc gross. So hierarchy chart shows you how they relate to each other. You also then want to figure out where the data is coming from and where it's going to go. So when the main function calls get hours worked, it does not pass any data to it. Get hours worked will have the user input the number of hours worked. It will check it to make sure it's a number that's greater than 0, and then it will return the hours worked to main. So main will call get hours worked, it'll get the hours, and then return that data to main, where it'll wait. Then main calls get pay rate. Get pay rate will have the user enter a pay rate, check it to make sure that it's greater than 0, and then return that pay rate to main. So then main will call get pay rate will be returned to main. So now the hours worked and the pay rate are residing in main. Then main calls calc gross. It sends to calc gross the pay rate that it got from get pay rate and the hours worked that it got from get hours worked. Sends them to calc gross, figures out the gross pay, calculating if they have overtime or not, and then returns that to main. Then main can display the gross pay. And main will also have the loop that controls how many times this executes. So it's going to be a sentinel controlled loop, one of those yes/no loops. So then you can go down and start to break down your code. So let's look at the main function. Look at the logic of it. So it's going to call each of the other 3 functions and display the gross pay on the screen. So basically I'm going to have an IPO chart for each of these modules or functions, because each one really is its own little program. So the input variables that will be part of this, what the user inputs in the main function, will be that process variable, and that's going to be that yes/no value that will control the loop and how many times the program executes. We also have 2 working variables, hours worked and pay rate. The user will not input them in the main function. The main function will get them from 2 other functions. So they're intermediate type variables. They are not input. The user will not input them in the main function. They're going to input them somewhere else. So really these are going to get assigned values through calculations, through the calling of a function. The output here is the gross pay, and we're going to display that. So I'm going to ask the user if they'd like to process, yes or no, get that process variable. While process is equal to y, then this is going to be a while loop, a top-driven loop. We're going to call the get hours worked function. That will assign a value to hours worked. We're going to call the get pay rate function. That will assign a value to pay rate. Then we're going to call calc gross. We'll figure out the gross pay and assign that to gross pay. Then we're going to display the gross pay, ask the user if they'd like to process again, get their answer, yes or no, end the repeat, and we'll go back up and check, and if they entered Y, we'll do the process again. If they entered anything other than Y, we will exit. And down below is the code for that. So this is a basic framework type of thing you've seen many times before, but here are the calls to the functions. So when we call hours worked, it's a value returning function, so it is going to return a value to a variable. The variable is hours worked. This is one of our intermediate values. Hours worked is not entered in the main function, it's entered in the get hours worked function. So that's why that's hours worked is an intermediate variable. Notice when we call a function, we have the name of the function, and then if no data is being passed to the function, you have the parentheses with nothing in between it. Okay. Value returning functions, again, generally have an equal sign in front of them because the value they return has to be assigned to something. It has to go somewhere. So get hours worked will return a value. That value will be assigned to this variable hours worked. Same thing with get pay rate. Now, when we call calc gross pay, this one's slightly different because we're passing data to it. We're passing the pay rate that was found or calculated by the get pay rate function, and we're passing the hours worked, which was calculated by the get hours worked function. So we send that data to calc gross, it uses that data, and then it returns the value to gross pay. When you see something like this, think of your Excel functions and how your Excel functions worked. So in Excel, I might have a function equal sum. Okay, and you see the similarity here. I have the equal sign and then the name of the function. In Excel, it's the sum function or the payment function or whichever function it is, equal sign, the name of the function, and then the data that's being passed to it. In Excel, you see cell references like A1 or B7. In Excel, the cells really are just variables. Okay. Then we call our another function here, set precision 2. It's a function we've been using for quite some time. We're passing data to that. This is not a value returning function. It's not that it doesn't do anything, it does do something. It modifies the cout command, but it does not produce a piece of data. It just changes the way the cout command works. And then we display our gross pay, and then we ask if somebody would like to process again. Ooh, this should say Y or N. Get the process. Remember, when they enter character data, we want to 2-upper it for make our checking easier. And this is our basic framework of the program. So that matches our logic. And let's go down and look at the other functions. Here's our get hours worked function. What this does is it gets and returns the hours worked. It's going to error check for an amount that is less than 0. So the input in this is hours. The user will enter the hours in this function. So what goes in the input column is what the user will be entering. The process, we're going to start the repeat, ask the user to enter the hours, get the hours, end the repeat when the user hours is greater than or equal to 0. So this is a bottom-driven loop. This will be our do-while loop. And then at the end, we're going to return the hours after it's been checked and we know that it's greater than 0. The output is hours. Whatever a function returns will go in the output column. And there will only ever be one thing in the output column. Sometimes it doesn't return anything, like set precision. And that's a void function. That we'll do in another chapter. So here is my function header. And the function header contains 3 parts. The name of the function. Can't highlight that. The name of the function, get hours worked, the type of data it will be returning. So this variable hours is a double. I'm going to be returning a variable of type double. And then in the parentheses, that's where we put the data that's being passed in. No data is being passed to this function, so it's blank in there. We define our variable hours. We start our do loop, do. Ask them to enter the hours worked, get the hours. If the hours is less than or equal to 0, we give an error message, please enter a value greater than 0. And then while the hours are less than or equal to 0, we're going to repeat this loop. So this double checks to make sure that they didn't enter a negative value for the hours or a 0 value. And then once we're sure that they've entered the correct thing, we're going to return hours. So hours is what's being returned. That's the output. We return the output, and here is where we tell the function about the type of data that's being returned. When that data is returned, comes back up in main and ends up here. So what is returned by the get hours work function is then assigned to this variable hours worked. The get pay rate function is almost identical. And then down here we have our calc gross function. This one accepts the pay rate and the hours worked for Maine, calculates and returns gross pay. And time and a half pay for hours over 40. So this one does the time and a half pay. Here's our logic. If the hours are less than or equal to 40, gross pay is 40 times pay rate, else gross pay is hours worked minus 40 times the rate times 1.5 plus 40 times the pay rate. So that's my time and a half there. Now my input, the pay rate, that comes from Maine. Hours worked, that comes from Maine. So they're going to be declared a little bit differently than they were, the input variables were in these functions. This one, the input pay, is entered in this function, get pay rate. So it's defined down here below the function. In this guy, pay rate and hours worked are two input. They come from Maine, so they're defined a little bit differently. They're defined in here inside the parentheses. This is how we tell C++ that the data in this function is going to be passed in. So really when we do this, we're creating two variables. I'm creating a variable, a double type, its name is pay rate, and another variable of double type, its name is hours worked. And when this function is called, these variables will be initialized with the values that are being passed in from the main function. Okay. So here we have the name of the function again. This is my function header, calc gross. We have the type of data that's being returned, double. And then we're declaring our input variables, but because the input variables are being passed from main, we're declaring them up here inside the parentheses. And then here is the code that goes with that. Figure out our gross pay and then is returned to the function. Okay. So let's look at the code. Now when we code these, this is a little bit of extra that we have to put in. These guys here are called your function prototypes. When we write our programs, we organize them so that the main function is the first function, and then the other functions, our other user-defined functions, are declared after main. It's just a better way to organize it. The problem with that is the compiler doesn't know those other functions, like in this case, get hours work, get pay rate, calc gross, are down below. So when it goes to compile, when we hit one of these lines where we call the function hours worked, it doesn't know the function exists. The prototypes fix that. The prototypes let the compiler know, remember the compiler goes line by line as it translates, that the functions are below there. It tells them the name of the function and what the data looks like that's going to be produced and what's going to go into the function. This is really, really simple. It's your function header with a semicolon at the end of it. So you already have your function header from where you declared your functions. You just copy it up here and you put a semicolon at the end of it, and you've got your prototype. So here's our main function. And then here are our functions, our other user-defined functions, and they've been declared below main. So here's my get pay rate. There's my header, my function header, double get pay rate. Notice that its prototype is exactly the same as a function header with a semicolon at the end of it. So let me see if I can line this up right. Show you how this works. So I'm coming down through main, I'm doing my thing, here's my process loop. I get to this line where it says hours worked equals get hours worked. That's a call to the get hours worked function. So it's going to come down here. Okay, looks, okay, no input, declares that, does my processing, finds out the hours, and then it returns the hours back to this function. So this is the value this function produces, and that's assigned to the hours worked. Get pay rate works the same way. When we call the calculate gross, what happens is these two values are passed down to this function. So when I call calc gross, it takes the value of this variable pay rate in main and copies it to the value of this variable pay rate down in the calc gross. These two variables have the same name, but they are not the same variable. They are two completely separate variables. There's a main pay rate and a calc gross pay rate. Names look the same, but they aren't. They're not the same variables. This pay rate is local to the calc gross function. It only exists in this calc gross function. It is created when the calc gross function is called and destroyed when the calc gross function ends. This pay rate belongs in main. So part of main cannot be accessed anyplace else. So variables are local to the function in which they are declared or defined, and they cannot be accessed outside. So that's why we're passing here. We're passing the value of this to this. So I'm really creating this variable pay rate in this function and assigning it or initializing it with the value that's in this pay rate that's up in main. This is part of the modularity of functions. So what happens here is I can do whatever I want to the pay rate down here, and it doesn't affect this pay rate here. So I really can't mess this pay rate in main up. Can't do anything to destroy it or to change it inadvertently. So again, part of the beauty of functions. Now it also passes this value hours worked down to here. Okay, so even though they have the same name, not the same variable. There's hours worked in main. There's hours worked that belongs to calc gross. Think of the function as like a last name. You know, there's Bob Smith and Bob Jones. They're not the same person. This is hours worked main, and this is hours worked calc gross. Not the same variable. Values are being passed from one to the other. Okay, and then it's returned, and then we come up here and we finish our process. So that is value returning functions.